So we're looking at the SR low active latch. So it's made out of OR gates with inverted inputs, and we also have our S and R flipped around. So when you're looking at these, make sure you really pay attention to the way signals are labeled. Actually, the first time I went to record these videos, I realized that I had a bunch of things labeled wrong and had to redo it. So the labeling does definitely matter. Anyway, so since it essentially acts the opposite way of the regular SR latch, when we have two zeros, that becomes our state that we're really not allowed to have. And how do we know that? Well, we see that Q and Qn are equal, which is something that we can't have because Q naught should always be the opposite of Q. And so that's the same as the 1-1 state for regular SR latch. So now we know about we know that negative logic says that our zeros basically act like ones in positive logic. So what that is kind of a roundabout way of saying is if I want to set the output to a 1, right? I want to set the output to a 1. Set needs to be a 0, and reset needs to be a 1. Just the opposite of a regular SR latch, and Q turns to 1. And that means that our steady state is 1-1, meaning when we go to 1-1, nothing should change. And now if I want to reset it, then I need reset to go low. And now reset sets Q to 0, and then we set everything back to 1. So that's how this low SR latch works in a nutshell.